So today we're going to look at hyperbolas. Hyperbolas are a mixture really of a lot of things from the ellipse and the parabola. It is still the set of all points equal distance from the foci, but these are your two formulas that you need to know. What is the difference that you see on these two formulas? The x and the y binomials are changing in these ones. Notice this time that the a squared and the b squared are staying in the same place. So they don't switch around. And this time a squared may not be the bigger number versus b squared. A squared could be 1 and b squared could be 16. That doesn't matter. What does matter is this transverse axis right here. The transverse axis is the axis where the vertices lie. And that's going to become important to you because it's vitally important that you understand where the vertices go. And we're going to do a quick sketch of what a hyperbola looks like in a minute, and then we will do a real sketch shortly. So looking at the two formulas, whichever comes first, that tells you the direction of your transverse axis. So on this one, because the x comes first in front of, oh, and the other thing we pointed out, we did not point out, was that we have a minus sign here. Whereas in the ellipse, we had a plus. So those are your two major differences. Since the x comes first on this one, the transverse axis is, what direction does the x-axis go? Horizontal or vertical? Horizontal. So because the x binomial comes first, your transverse axis will be horizontal. Whereas on the second equation right here, the y binomial comes first, so your transverse axis is going to be vertical because the direction of the y-axis is vertical. Then I will not make you memorize the equations for the asymptotes. I will actually give you those, but they're really not that hard to remember if you look at them. They're not too tough. The only difference in these is the a over b versus b over a. And then the only other two things that are important for you to know would be how to find C. I wouldn't focus on, A being the vertex on the real axis, B on the imaginary. I wouldn't focus on those. That's not important. You'll see why in a minute. Your foci for each of these, for those of you who like to memorize those formulas, are as follows. So your foci, if the x binomial comes first, would be h plus or minus c comma k. Remember, your foci is always c units from the center. That has not changed with a hyperbola. And so over here, your foci are going to be h comma k plus or minus c. Do note that when we find C for our foci this time, how is this different from our ellipse Pythagorean relationship? There was a minus in the ellipse. This time it's a plus. And so to remember that, these are opposite signs here. So if you have a minus in your standard formula, you've got a plus here in the Pythagorean relationship. If you have a plus in the standard formula, you're going to have a minus here in that Pythagorean relationship. All right, so just look at a sketch of what a hyperbola looks like, and we're going to sketch both of these just as real brief sketches. So for chuckle's sake, let's put your center at 0, 0. And then because our x binomial is coming first on this one, that means our transverse axis is going in the direction of the x-axis. So I'm going to plot just a dashed line. I'm going to put a point here to the right and a point here to the left. These are going to be your vertices because your vertices are always on your transverse axis. So this is our transverse axis. It's kind of hard to see because it's the x-axis, so I'm going to kind of go above it there. I missed it just a smidge, but that's your transverse axis. So if I were you, I'd label that as transverse axis. If I try to label it on my notes, it's going to get all gunked up. But you can put an arrow on there. And then the other axis is called your conjugate axis, and it's going to be a certain distance above C and a certain distance below C. It's going to be that B distance. And so if you drew a dotted line through the center, that's your conjugate axis. Your book likes to call it the semi-transverse and the semi-conjugate axis. It's just a difference in publishers. Some publishers have the semi in there and some don't. So you're going to find A and B, and you're going to create these axes, these 4 points. The 4 points then can create a rectangle. So if I were to create a perimeter, so to speak, around those 4 points, a rectangle is going to be made. This rectangle is greatly important in the shape of your hyperbola because that rectangle is going to give you your asymptotes. Your asymptotes are diagonal lines that go through this rectangle and through the center, and they're going to extend past. So these are going to be, of course, you're going to use a straight edge. I can't on here, but you're going to use a straight edge because if you don't use a straight edge, you're not being very accurate. So these are your asymptotes. So you can draw that in. And again, because my vertices are here on the transverse axis, they are the vertices for my hyperbolas. And the hyperbolas just look like two parabolas that are opening in opposite directions to each other. So once I have my asymptotes in place and my rectangle in place, I can go ahead and draw my hyperbolas. And so here we go. You're going to hug the asymptote and go through that vertex on both sides. So there's half your half of your hyperbola, and there's the other half. So those asymptotes really give you the shape to that hyperbola, whether they're really wide or really narrow. Versus when I had you graph your parabolas, remember I didn't care how wide or narrow the parabola was. I cared about your vertex and your focus. This time's a little different. I do care about the shape because you can actually get the shape by easily plotting in your asymptotes and this rectangle. But you have to be using straight edges, unlike what I'm demonstrating here. What's missing? What's missing? That we've had in parabolas and ellipses that we don't have on here yet? The foci. So your foci are, again, going to be hugged and protected by those hyperbola curves. So they're going to be inside the curves. So this time when the y binomial comes first, like this one is, we're going to sketch the same thing, but our transverse axis is going to be going vertical. Now your transverse axis may or may not be the longer or the shorter axis. It doesn't really matter. But let's go ahead and put our center in. So again, for chuckle's sake, our center here is at 0, 0. And then we're going to plot our transverse axis going up above, there's a vertex, and below C, the center, going in equal distances. And so technically this right here is my transverse axis. From vertex to vertex is the transverse axis. And it's important that you plot that first, and that distance is A. A is the distance from V to C. Half that distance, just like it was on the ellipse. That hasn't changed. Then you're going to want to plot your B distance. Your B distance is your conjugate axis, and it goes to the right and the left in this case, only because B is underneath the x-axis. So it's going to go to the right and the left. And so we're going to plot those points. I'm going to plot a point here and a point there, equal distance from the center. And then from here I can draw my my rectangle using a straight edge, of course, as I'm sure you are, right? Of course you are. And then we'll draw in our asymptotes. They will be the diagonal of the rectangle going through the center. And then because my vertices are on the transverse axis, I can now plot my hyperbola hugging those asymptotes and hitting that vertex, which I kind of missed on that one. And then don't forget your foci are being surrounded and protected by those curves. So those are just quick sketches. So some things that you might want to add in here if you haven't already. So on this one is the transverse axis. And then this one right here, that is the conjugate axis. Bless you. Whereas on this one, this was our transverse. And this one was our conjugate. And of course you can see our asymptotes there. So that's what a hyperbola looks like. They look like parabolas that are mad at each other. And you can think of it also in this way. If your x comes first, then these are opening right and left, which is the same direction as your x-axis goes right and left. And if your y comes first, these are opening up and down, which are the same direction as your y-axis goes up and down. And in addition to that, you can kind of connect this to the parabolas. When the x was squared in the parabola, didn't you have a parabola? Oh, no, you really can't. That's not good. That would be backwards, wouldn't it? So think of it in terms of x and y axes. So any issues or concerns before we actually graph them for real? All right, so look at example 1. So the first thing I want to note in example 1 are a couple things. My x binomial comes first, so what does that tell me? What's horizontal? Yes, so the transverse axis is horizontal because of that squared, the x binomial is coming first. That doesn't even look like the word horizontal, does it? Make it nicer. All right, then number 2, what can I tell? What can I tell immediately? The center. Everything revolves around that center. So we want to find our center. What is my center? -1, because that's what the x, and +4. So we're going to sketch out. And bear in mind that your A is going to be 12. So we're going to have to, and it's underneath the x, so we're going to have to go right, left 12. And your B is 5, so you're going to have to go up, down 5. So make sure that you make this axis from -1, 4 to be able to go out to 12. So the left side you're going to want to go out to 14, and the right side you're going to want to go out to at least 12 or 13. I'm going to go up 5. Well, actually from 4, so we're going to want to go up to 9 or 10. Thank you. Okay, so plot your center. And from there, what do I want to find next? I need to find my two axes, both my transverse and my converse axis lengths. So in order to do that, I want to find A and B. So I know that because A squared always comes first on the hyperbola, I know that A squared is represented by 144. So that means that A is what? 12. Is that going to be a right-left or an up-down movement? Because the A squared is underneath the X.
It could be right-left.
So it will be right-left. So I'm going to plot 12 to the right of the center. So from the center, I'm going to go 12 to the right. Where does that place me at if I'm at -1? So -1 plus 12 is going to put us at 11. So 11,4 is correct. Now it's probably to your advantage to be putting a straight edge along here so that you can get these identical, especially because it's so long, to get them identical heights up and away from each other. And so then to go to the left of center, I want to go 12 to the left. So what's -1 plus that -12? Because we're going to the left. Yep.
We're playing dash line always.
Yeah, and so we're going to call these vertices because that is our transverse axes, because it's the one that came first. And so I'm going to connect those with a dashed line just so that we can see that axis. So that we just drew is your transverse axis. That means that your hyperbolas are going to be opening left and right along here. But we now need to go find out how high, because this is the width of a rectangle. We have to be able to go high enough. And so let's find B. So B squared is equal to 25, so B is equal to 5. And so B will be going up, down, because it's underneath my Y. So that is an up-down direction. So plot, I'm going to plot that in purple. So plot your B going up 5. So from a height of 4, up 5 would put us at 9, wouldn't it? And then down 5 from a height of 4 would put us at -1, -1. And so before we connect and make our rectangle, let's name our vertices. So our vertices are only the two that are on the transverse axis. So what's this vertex to the right of center? What's that order pair? 11, 4 is correct. So we have one vertex that is 11, 4. And the other vertex, which is left of center, is this one, which is what? -13, 4. So we've named our center, we've named our two vertices. Now we need to draw in our rectangle and our asymptotes. So that's our next step. Whoops. So step 4, draw in rectangle and asymptotes. So that's what we're going to do. It would be to your advantage to put the 4 corners of your rectangle up and down here using your straight edge, and up and down here before you actually connect your points. So I know that I have a corner here to my rectangle, and I know down here at 11, -1, I'm going to have another corner, and at -13, -1, I'm going to have a corner, And at negative 13.9, I'm going to have a corner. So using a straight edge, of course, you're using a straight edge, right? It's hard to see the bottom of my box because everything's in red. But there's the rectangle. And then you want to use a straight edge and connect your diagonals going through the center and extend those diagonals, those are your asymptotes, as long as you possibly can because it gives a shape to the hyperbola. Oh, I totally missed that. Let's try again. Okay, so there's your asymptotes, but we do need to find the equations to those asymptotes and the foci. So let's go ahead and draw in our hyperbolas, and then we'll find the equation of the asymptotes and the foci. So step 5, draw in the hyperbolas. So all I have to do is follow from my asymptote, hit the vertex, and hug that other asymptote on both of those sides. So we're just drawing them in. So then let's find the equation to our asymptote. So step 6, equation of the asymptotes. So I'm going to give you that equation, but if you look at the other side, the equation is y equals k plus or minus b over a times x minus h. And we're using this one because x comes first. And so we're just going to fill in what we know. Y equals plus or minus here. And so we know k from our center is 4. And then to find your x value, just look at what is inside the parentheses for the x binomial and put that in the parentheses here. And so we have x plus 1 in the original equation, so the x plus 1 goes there. We found b earlier to be 5, and we found a to be 12. Can this fraction be reduced? If it could, you would, but it can't, so this is the formula that we're looking for. So that covers both asymptotes. Yes?
I just know which of the equations to do.
Because based upon what I gave you on the other side, if x comes first, oops, sorry about that. If x comes first, then your b always goes up top. But I'll give you that.
Okay.
If your y comes first, then the b goes on the bottom.
Or where the x minus h, or like why did you put x minus 1?
Because that's the way why did I put this? Because x minus h, isn't this x minus h here in the original formula? So those are the same, that's why those are identical. Any other questions before we find the foci? Sierra? The center, k comes from the center, h. The h technically also comes from the center, but because it was x minus h, we just took the whole x minus h that was in the original. Okay? All right, so then the last piece are your foci. And so that step 7 is your foci. What do we need for our foci? We need c, right? So c squared is equal to a squared plus b squared. Well, we know our a squared and b squared because we have them right here, a squared and b squared. So we're going to use those previously. So our a squared was 144. And our b squared was 25. What do those add to give you? Yep, 169. What's the square root of 169? 13. So that means that our foci are 13 units up, down, or right, left from the center. Here's your transverse axis. And your hyperbolas have to hug those, so it should be right, left. So you might want to write yourself a note that this is right, left. So we're going to go 13 to the right and 13 to the left. So if I go 13 to the right of center, and my x value at center is -1. So if I go 13 to the right, where does that place me? What's -1 plus 13? At 12. And so, yep, 12, 4. So there's your focus. And we can name that. So one focus is 12, 4. And the other focus, well, let's talk about it. So we're going to go 12 to the left. I'm sorry, 13. 13 to the left. But we start at -1, so -1 plus -13 puts you at, yeah, -14.
Do we just have to put effort and we put the foci down somewhere else below?
Now you have to label F up there and
Yeah.
then label your, it's too much to label your ordered pairs in the picture.
Yeah.
So then this is going to be -14, comma 4. So any questions about what we did on that? Are we good? A lot of it's similar to the ellipse. Isaac? I can't hear you there. Oh, you're copied down. Okay, I'll wait. You good? Still copying? Is Ben's big and powerful brain in your way? Yeah. Just sitting there. Are we good? Anybody else need to still copy? No complaints? All right. So look at. So this time it's very similar again to what our example 2 has been in 8.1 and 8.2. We have to do what first?
Solve the
Yeah, we have to get this into standard form. So to do so, I'm going to put my y terms together, which are those, and then I'm going to put my x terms together, which are those two. And then we're going to move this 47 over to the right side by subtracting it. So here we go. So we get 16 y squared plus 64y. And then don't forget your plus blank. And then minus x squared plus 2x plus blank equals -47. And then we're running out of room. But we'll have a plus blank and another plus blank. One for our y's and one for our x's. What do?
Does it matter if the y squared or the x squared go first?
Very good question. We're just going to talk about that. There is a difference as to which one of these come first. And so look at your general form for your hyperbola. The positive one comes before the negative one. And so because your x is negative, that's why the y squared comes first. Your x squared is negative. So if it had been reversed and we had 16x squared minus the y squared, the x squared would have to come first. So whichever one's positive must come first. So good question. And then what else have we learned about completing the square here? What do we have to do first before we complete the square? Yeah, your coefficients here have to be a positive 1, and that includes over here on the x squared as well. That negative x squared needs to be a positive 1x squared. And so we're going to take out, or factor out, the 16 from the blue term. So 16 parentheses y squared. What is 64 divided by 16? Not 3, but 4. So I get 4y plus blank. And then we're going to factor in negative from this x term. So we've got negative parentheses x squared. That makes this a minus 2x plus blank. Oy, this is cutting me into my other. That was that other one. So plus blank, and then I'm running out of room. So equals, and then other side I have negative 47 still, but what happens on my plus blanks for my blue?
Or 16.
You have to have a 16 times whatever you put on the blank. And then for the green, we're going to have plus a negative times whatever comes on that blank. So now let's complete the square. So for the first one, we're going to take 4, divide it by 2, and square it. What do I get? What does that give me? Not 2, but 4. So I put a 4 on each of those blanks. And then for the green, I'm going to take the 2, divide it by 2, and square it. What do I get? 1. So put a 1 on each of those blanks. And now do your math. So we've got 16 with a squared binomial. Take the square root of your bookends, so y and 2. And then the sign of your middle term becomes the sign in your binomial. So because our middle term is positive, we have a plus 2 in there. Then minus squared binomial. So take the square root of your bookends, x and 1. And then because the sign of our middle term this time is negative, put a negative down here in the binomial. Equals, and then this time I'm going to split it with a purple line. So equals are negative 47. And then what's 16 times 4? So plus 64, and then negative times a negative 1, or negative times a 1, sorry, is a negative 1. So adding those three together, what do you get? 16. So we get 16 times y plus 2 squared minus x minus 1 squared equals 16. What does this have to be? A 1. Always on the hyperbolas, the right side's a 1. So we're going to divide this by 16, and so does every term, which coincidentally caused the 16s both here to cancel and here. So technically, your equation should read y plus 2 squared minus x minus 1 squared over 16 equals 1. This is the equation I want to see on my test, but Math Excel might require you to put this over 1 because of how they write the algorithm for your answers, because there's usually like 10 different possible.
Would you mark us off?
I would mark you off if you put it over 1, because you're not supposed to put something over 1 unless it's a ratio. So you need to note to self, Math Excel, you might have to put it over 1 because of how they write their algorithm for the answers. But for Mrs. Murray, you better not put it over 1. However, we do need to view it as being over 1 for our graphing purposes. Graphing purposes only. So as we prepare to graph this, I need to find my center first. So step 1, what's my center?
No, 1, negative 2.
Yeah, your 1 is with your x, so 1 is your x value and your negative 2 is your y value, and that's so easy to mess up. I do it all the time. And so then bear in mind that your a is going to be 1 and your b is going to be 4, so we really don't have as big of a 1 as we had before. So All right, so as we plot that center of 1, negative 2, we end up right here at the center. Looks like an E, but it's really a C. Then from there I need to find my A and my B so that I can graph my rectangle. So step 2 is to find A and B. So what does A squared equal? 1, and so A is equal to 1. This time, is that going to be an up-down direction or a right-left direction if my A squared is underneath the Y? So it's up-down. So that's up-down. So that's my transverse axis. So it's important that you plot that first. So I'm going to plot 1 above and 1 below my center. So 1 above would be here at 1, negative 1, and that's a vertex. So label that with a V. And then 1 below would be right here. Label that with a B. So let's name those vertices. So what's the point above? What's that order pair again? 1, negative 1. Whoops. And what's the point below center? 1, negative 3. So there's our center and our 2 vertices. And then we still need to find B in order to fill in our rectangle. So B squared is equal to 16, and that means B is 4. So is that up, down, right, or left? Because it's underneath our X. So right, left. So we're going to plot our B 4 to the right and 4 to the left. So it's kind of nice to put in your transverse and your conjugate axes. So here's the transverse axis, and here's the conjugate axis. So this time our transverse axis is much smaller than our conjugate axis. Again, the transverse axis is not necessarily the bigger one, but the transverse axis is where the vertices to the hyperbolas belong. And so at this point, you can plot your asymptotes and your rectangle. So that's what we're going to end up doing. So step 3, draw in asymptotes and rectangle. The rectangle needs to come first. So here we go. You're using a straight edge. I'm not. And you're going to want to put in your corners above here. So here's a corner that goes here, one here, and one up here. So you're going to plot those corners first. So at 5, negative 1, at negative 3, negative 1, at 5, negative 3, and at negative 3, negative 3. And then that becomes a dashed line. Maybe I'll make that a little purple line since it's... Alright, so there's your rectangle, and then you want to draw with a straight edge your asymptotes that go through the diagonal of the rectangle. That includes the center, and extend them as long as possible. Those are your asymptotes. That was really sad looking, but you're using a straight edge, aren't you? Now, are my hyperbolas going to open right, left, or up, down? Here's where your vertices are. So they're going to open up, down. So then we can actually draw in our hyperbolas. So step 4, draw in hyperbolas. So follow that asymptote, hit the vertex, and follow the other asymptote. Same thing over here. So our hyperbolas are very wide and flat, and they open up or down. So let's find the equation to our asymptotes and our foci. So equation to our asymptotes, so I'm going to put down here, the equation for asymptotes. This time we're going to be using y equals k plus or minus a over b times x minus h. Why? Because that's the formula that goes with the hyperbola that when y comes first. So you're just going to use that as a template, and you're going to plug in the values that we know. So from our center, we know our h and our k. So our k was -2, and our x, right here, x minus 1, goes right over here, x minus 1. And then our a was 1, and then our b was 4. So this is the formula for both asymptotes. And you, of course, would reduce this fraction if you could, but you can't. So all that's left is our foci. So last but certainly not least is our foci. Oh, I guess I have 2 4s, don't I? Well, let's make this a 5, and let's make this a 6. Foci. What do I need for foci? Yep, so c squared equals a squared plus b, plus b squared. So I know a squared and b squared. Well, I know that, so I'm going to use, my a squared is 1 plus my b squared is 16. So c squared is equal to what? 17, and what does c equal? Square root of 17. So we have to find the distance, because that means that our foci are square root of 17 from the center. First of all, is that going to be an up-down distance or a right-left? Because y is coming first, right here, that's going to go in an up-down direction because it's got to go with our vertices. So we are going in an up-down direction. And we have to find the perfect squares that are to the left and the right of 17. So what perfect square is to the left of 17? So square root of 16. Throw that in there. And then that's 4 times 4, so 5 times 5 would be 25. That's hard to read. Let me move it over a little bit. So that's a 25. So that means that we're going to go 4.5 above the center and 4.5 below the center, but that's not how we're going to label our foci. So we're going to go 4 above from center. We're going to go up 4. So that puts us at, yes, between 2 and 3. And then 4 below, oh, 4.5. So we're going to go somewhere between 6 and 7. So there's our other focus. And so then we need to name them properly, those ordered pairs. So what is changing on this focus from the center? So here's our center. What value changed when I went up? Was that the x value of the center or the y value of the center? So here's our center right here. We just went up. Did that affect the x or the y value? The y value. So our x value is the same for our foci. So our foci still has an x value of 1, But then we took the -2 and we added the square root of 17 to it. That's how we went up. For the down, we still had 1, and we went from -2, we subtracted or went down the square root of 17. So those are your 2 foci. There's a lot of work associated with those. Questions before we do the last example? Most of it is just drawing and identifying, or using a formula and plugging in. Good, any complaints if I move? Okay, so let's look at the last example, and just like the last example has been in 8.1, 8.1 and 8.2, you're given pieces and you have to find what you need for the equation. So what do I need to write the standard equation of a hyperbola? What do I need to know? The center, which is h and k. What else? The who? A and b. So those are the only 4 things that I need. So here they've given you the vertices and the foci. What do you know about the vertices and the foci? Where do they both lie on? Yeah, these both lie on the transverse axis. Both of them do. So if I plot my vertices, let's go ahead and plot those. So if I plot my vertices of 2, 3, there's 1 vertex, and 2, -3. There's my other vertex. What do I know about the distance here from vertex to vertex?
3.
Well, that's not the distance. The distance is 6, right?
Oh, that's not
But half that distance, so from here to here, doesn't half that distance equal A?
yeah.
Which, as Kevin just said, is 3. So that's important. So a couple things I've learned. Step 1, what do we know about our transverse axis? Is it vertical or horizontal? The other thing that we just learned was that A was equal to 3. What else can I learn just from the vertices? The center. So the center is halfway in between, which is right here actually on that x-axis. We also have found the center, which is what ordered pair? 3, 0. And what that has given me is my h and my k. So now I've found A, my h, my k, what's left? What else do I need? B. Courtney.
How do you get center from 3, 0 if the vertices are 2, 3, and 2,
Oh,
-3?
yeah.
Oh.
0.
Yeah, then I totally plotted those wrong. Gotta love me for that one. Thanks. Okay, well, no. Hopefully that didn't just really happen. Okay, so let me just fix this really quickly. So I'm going to take that out, but we're going to just replot everything. Thanks, Courtney. Because that's going to affect everything, right? All right, so we have 2, 3, vertex, and 2, -3. So our distance from here to here, and from here, so here's our A, still 3, and our center is still, but this time our center is 2, 0. So our transverse axis is vertical. Our A is 3, and our center is 2, 0. So that gave us our H and our K. So all that's left is B, correct? Well, we haven't used our foci yet. Our foci are going to be plotted at, let's use that. So our foci is going to be at 2, 5, and then at 2, -5. What help is it for the foci? What do I know about this distance from here to here?
Let's see.
That is C. And so how far is C? 5. So from our foci, we learned that C was equal to 5. But I don't want C, I want B. How is that going to help me? So we've got C squared is equal to A squared plus B squared. But this time I don't know what C squared is or what A squared is. I'm going to have to calculate that. But I know that A is 3 and my C is 5. So I end up with 25 equaling 9 plus B squared. So when I subtract 9, what do I get? 16. And so B is indeed 4. So that's important. Because my transverse axis is vertical, what does that bring me to understand my equation to be? Because we have everything we need for the equation. So do I have an equation where the x binomial comes first or the y binomial comes first? Because vertical is the direction of the y-axis, the y has to come first. So I know that we're using y minus k squared over a squared minus x minus h squared over b squared equals 1. So we're going to use that as our template and then just plug in what we know. And then from our center, we get 2 is our x value, 0 is our y value, A is 3, and our B is 4. And so our final equation, you have to take care of the 0, is y squared over 9 minus x minus 2 squared over 16 equals 1. I will talk about the bottom part tomorrow. It'll take me literally 1 minute to explain. If you look at it, I think you'll be able to answer your Math Excel questions. Okay, then the final part, it's very brief. You need to look at any equation given in this form. So it's not in the standard form of a parabola, an ellipse, or a hyperbola. If you look at an equation in this form, focus solely on the coefficient of the x squared term and the coefficient of the y squared term. And then follow these 4 rules. If A and C are exactly the same number, like 1, 1, or -4, -4, or 2, 2, it has to be a circle. And then the rest of them all deal with products. If A times C is 0, for A times C to be 0, you must be missing either the x squared term or the y squared term, because that means that the coefficient is 0. And so if you're missing the x squared term, you only have one squared term, the y squared term, it has to be a parabola. Same thing if you're missing the y squared term and only have the x squared term, it has to be a parabola. Remember, the parabola is the only equation that has one squared term, whereas the ellipse and the hyperbola both, and the circle, both have 2 squared terms. For the ellipse, if you multiply the A and the C together and they give you a number greater than 0, it's an ellipse, because remember, the ellipse standard form has a plus in between the 2 fractions, and the hyperbola, as we just saw, has a minus in between the 2 fractions. So if the product between A and C is less than 0, or a number that's negative, then it's a hyperbola. So you need to study and learn all of these rules.